Good morning. Can you hear me? Can you see the blackboard?
Yes.
Yes, sir.
Okay. Yesterday we finished the motion in y direction before we finished the motion in x direction. Both of them are the motion in just one dimension, even horizontally or vertical motion. Today we will study the both directions, x and y, by studying the projectile motion. But when we study them now, you will see that we just study the horizontal and the vertical motion alone. But later, when we finish the question, we will see that we solve a question or a problem in two dimensions. From before, we know that equations of motion, which are in x direction in horizontal motion, V2 is equal to V1 plus A multiplied by T. V2 is squared is equal to V1 squared plus 2AX. X is equal to X naught plus V naught X in X direction, T plus half A T squared. This motion in X direction, look, the velocity in X direction, also the acceleration in X direction, it is AX. It is the acceleration in X direction. We have the same equations in Y direction. Vy2 is equal to Vy1 plus Ay, which is G, the acceleration due to gravity. Okay, multiplied by the time. The velocity has a direction, so we have Vx and Vy. The position Y, we have a position X. We have X and Y. We have acceleration in X direction, which is AX, and we have an acceleration in Y direction, which is G. And we need to know where is our positive and negative directions in each problem. The time is the same. In X direction or in Y direction, we have the same time. The time is general here. Okay. So these are the three main equations of motion. And also we know the position vector from before, which is R as a vector is equal to X component in X direction plus Y component in Y direction, J direction. Also we know that there is a velocity vector, which is Vx in I direction plus Vy in Y direction. And also we have an acceleration, which is Ax in X direction and Ay in Y direction. We have in Z direction, but we will not talk about it. Okay? Now, these are the main tools we need to use them in this problem. The projectile motion. Let us talk about projectile motion. If I throw an object with zero angle above the x-axis, above the horizon, like just this eraser, like this, it's a projectile, but with angle equal to 0 with x. It is a motion in one direction. What if I do this? It's a projectile motion with angle equal to 90 degrees. It is a motion in one dimension, as you see now. But what if I have an angle? When I throw this like this, I have an angle like this. I have angle theta or alpha. You can name it as you like. In the notes, I name it alpha. Okay. So the motion, the initial motion for my object with angle alpha and with velocity v0. This is at time equal to 0, at t equals 0. So the velocity, it is a vector quantity, and alpha, it is alpha at time equals 0, which is alpha 0. I named them by 0 because later I have different values for them. For example, this is my alpha, this is V0, and this is alpha 0. You can see later, if my motion like this, if I name this point, for example, 1, then I have another angle. I have alpha 1 and V1. If I am at the top of my motion, the maximum altitude, here, I have this velocity. I can name it V2, and I have also alpha 2. What if I am here? I have this velocity, which is the tangential direction. This is V3, for example, if this point is V, and this is the X. And this is the angle, alpha 3, or be careful. When I need to measure, when we need to measure any angle, we need to measure it counterclockwise, like this. What if I have to be the same, the end? What if I have this angle? I need to measure my angles from the positive x direction. This is angle, my angle. What if my angle is here? My vector. Yes, you're right. You can tell me this is minus maybe 60. But in our solution, we need to measure it. We need to measure this angle. How much is this? It is 360 minus 60, right? So it is 300. But if you need to find sine minus 60, it is the same as sine 300. The sine of this angle is the same of this angle. It is negative. The sine is the y component. Also the cosine. Cosine minus 60 is equal to cosine 300. So it is okay to measure the angle from the negative side, from the negative direction, but you need to put in your mind, this is our angle. Any questions about the angles and the angle measurement? And be careful until today, until now, and the first midterm exam, we need to deal with angles in degrees, not in radians. Okay? Now, in the projectile motion, we need to consider our origin. This is our origin, the starting point of our motion. The second thing, we need to consider the positive and the negative directions in X and Y. Maybe we can measure, or we can use, this is the positive direction upward, and this is the negative direction with respect to Y. For X, we can consider this. This is the positive and this is the negative direction. Okay? The third point, we don't have any friction force due to the air. Okay? Our experiment is an ideal phase. But in general, to know that if you are athlete, for example, you play some sport and you study in physics, this is the projectile motion for a ball, for example, or something. Be careful. Ideally, or without air friction force, there is a symmetry between the two parts of the strip, okay? But with air friction force, will be like this. There is a friction force in y direction and in x direction. This will reduce the range. I will talk about it, and it will reduce also the highest point. Now, let us understand some things about the x and y direction. Now we know the positive and the negative direction in each direction. Okay. Now for y. Let us start for y. The velocity for y is changing. You can see when I throw this, the velocity come to be 0 at the highest point like this. If I start, for example, by 10 upward, here it will be 8. Then, for example, 5, 2, 1. At this point, the object cannot go upward. So its velocity here is equal to 0 at this point, at the highest point. Then it will start again going down as a free fall. Then its velocity will be again 1, 2, 5, 8, then 10, but with the opposite direction. Because we don't have any friction force, then at each altitude we have the same velocity. This is the y motion. This is the velocity. What about the acceleration? Okay, the acceleration, which acceleration we have in y direction? Who can tell me? It is there. Isn't that the question? What is the acceleration we have? It is g. It is the acceleration due to gravity. And it is downward. We have g, always downward. Because of that, g is negative. The velocity when I am going up, it's positive. The velocity when I'm going down, it's negative. Just like the previous example that yesterday. Okay, another important thing. When I was new place, I answered it the wrong way. G is always constant. When I am going up, G is G, it's constant. It is negative 9.8 meter per square second. There is always G. How much G at the top? How much G here? The velocity is 0. But G, it is still the same. To tell you, when I am in your place, I answer it to be 0, but it's not 0. Because of G is always constant, then the object will be allowed to return its motion direction and go down and increase its velocity again. So G is constant always in my equations. The altitude, y. I have, this is y0, the 0th level. This is y max. Y max. At y max, the vertical velocity Vy is equal to 0. Okay? Be careful about this point here. This is all about y, I think. What about X? We don't have any friction. X, we don't have any friction force. We don't have any force will increase the velocity in X direction. Also, we don't have any force will decrease the velocity in X direction. So, the velocity in X will be constant. So, Vx will stay the same at all the range. The maximum X distance, we can name it range. We don't have any acceleration in X direction. Ax is equal to 0. Ax equal to 0. Ax equal to 0. Ax equal to 0. Sorry. So we don't have this term. We don't have this term. We don't have this term. Okay. We have the equations now in X direction. V2 is equal to V1. V in X direction is the same. V2 square is equal to V1 square. It's the same equation. This and this. X equal to X naught plus Vt. V in X direction. It will not change. It is the simple velocity equation relation, right? Now, we will use the position vector, the velocity vector, the acceleration vector to solve any problem. Okay, R in X direction. X, where is X? This is X. So we can put it X equal to X naught, and X naught at this point, you can assume X naught equal to 0 and Y naught equal to 0 if you like. But I will keep it here. So I have R is X naught plus V naught T in X direction. This is Vx. What about Y? I need to put this equation. Okay. This is Y naught plus Vy naught T plus half GT squared. All of this in J direction. Okay, what is Vy and Vx? It's simple. You know that from before. It is vector operation. This is V naught. This is alpha naught. What is X? Naught. It is V naught cosine alpha naught. What is Y naught? Sorry, this is V. This is V X naught. This is V Y naught. It is V naught as a magnitude. Sine alpha naught. I need just to use sine and cosine. This is V naught at here, at this point. For X, it will stay the same. It will not change its magnitude. For Y, it will change its magnitude. Vx will stay the same. V naught cosine alpha naught. Vy, I can use this. It's okay. I can use this. It's okay. Vy is, for example, keep it Vy. J. What about the acceleration? What is the acceleration in X direction? I will open the chat. And okay. What is the acceleration in x direction, online or offline? We just talked about it. It's 0. What is the acceleration in y direction? In y direction, it's just g. This is the acceleration vector. We have everything to solve any problem now. Any question about projectile motion? We will start solving examples. The different examples, even if you look in the textbook, you have a zero approach, you have a general approach, you have a vertical approach. They mean by that if we change theta, alpha. If alpha is equal to 0, this is a 0 approach. If alpha equal to 90 degrees, then this is the vertical approach, and so on. We will solve it in general, and we can solve any problem. Okay, if you look at page number 9, there's the first example. I guess before that, we can use the Pythagorean theorem in page number 7 to find the distance, also to find the speed, and to find alpha. Alpha at any point, you can just know, yes, this is for the next chapter. Now we're talking about the projectile motion. Do you have the notes? Okay, let us start with this example. At theta equal to, at alpha equal to 0, then I start from alpha equal to 0. It's the same if I start from here. Just by, you can see the figure, you can understand it. As I told from yesterday, I think from now on, you will see every example is solved with you in the notes. It is given that V naught is equal to 2 meters per second, right? What about alpha naught in this case? Who can tell me? Horizontally, my velocity starts horizontally. With respect to x direction, V naught is equal to 0 degrees. And we have the motion of this object like this. We have the object later with Vx with velocity in x direction, with Vy in y direction. Also, it has its angle alpha later. It's the same. This alpha or the 360 minus this alpha, the same. Find the position vector and velocity vector as a function of time. We can see here. Now, what is Vx? The position vector is, let's talk about the position vector. R is equal to Vx I hat plus Vy k hat. Okay, what about Vx? Vx is equal to Vx node cosine alpha node. What is Vx node? What is the velocity here? V naught. Let us talk about V naught. I'll put it here. V naught. It is 2 in I direction plus 0 in J direction because it is horizontal. There is no component in Y direction, right? This is we know as a vector. And alpha is 0. Okay, Vx naught, it is 2. Cosine 0, which is 1. So our Vx is equal to 2 meters per second, always. There is no friction force in this direction. What about Vy? No, Vy naught is equal to 0. You can see it. What about Vx? It is always Vx is equal to 2. It will not change its magnitude. What about Vy? We can use this, we can use this. Let us use this equation. Vy finally, or at later time, it will be equal to Vy naught plus G multiplied by T. Okay? It is equal to Vy naught is 0 plus G is negative 9.8 multiplied by T. As a function of time, Vx, it is constant. It is just 2. Vy, it is 0 minus 9.8, which is negative 9.8 T in J direction. This is the position vector for our motion. Right? No, this is the velocity, I'm sorry. I need the position. This is the velocity. I will use this for the velocity vector, it's okay. This is the velocity, but I need to use the this is Vx. What about x? I need to continue. I just find the Vx. I need to find Vx. X is equal to x naught. If I assume here 0, 0, then x naught is 0. V naught is 2 multiplied by the time. So x is equal to x naught, which is 0, plus V naught multiplied by T. V naught is T, and V is always 2. So it is 2T. This is x as a function of T. This is x of T. I will use it here. 2T. I just solve the velocity and I will use it in the velocity vector. What about y? Now I just find Vy of T. I need to use it here. Why? It is equal to y naught. Y naught I can assume it's 0, just as I did here. But the negative direction downward. Plus V naught multiplied by T. V naught y multiplied by T. V naught, if you remember, is 0 also. Plus 1/2 G. It is negative 9.8 downward because it is so it is negative multiplied by T squared. This is y of T. This is y of T. It is just a function. F of x is equal to x squared minus 3x, for example. F of x, y of T. It's a function of time. So my function of time position, it is negative 9.8 over 2 multiplied by the time. This is the position by the time squared. Any question about this point? What about the velocity? We found the velocity now. V as a vector. We found that the velocity in x direction is 2. I had, it is constant, plus negative 9.8 t j dash. If I ask about the acceleration, who can tell me? What is the acceleration in x direction? What is the acceleration in y direction? Just give it 0 g. Now, if I ask you, what is the x position after 1 second? I will write that the vectors here. And we know the acceleration. If I ask you at t equal to 2, what is x of 2? You need to choose the position vector. X, I need to use this part. T is equal to 2. 2 multiplied by 2, it is 4 meters. What is y of 2? T equal to. You need to use this part. It is negative 9.8 over 2 multiplied by 2 squared, which is 4. It will be equal to negative 19.6 meters. Negative. Why it is negative? Because it is downward. It's there. Because I am on the top of a building and I am looking downward to that object. You can use any time to find the position anywhere in x and in y. What about the velocity? It is the same. What is the velocity at x equal to? I need to put 2 in t here. There is no t. So there is no meaning for the time. The velocity is always 2. What about the velocity in y direction at t equal to? Okay, put 2 here. It is negative 9.8 multiplied by 2 in y direction, which is negative, downward. That's it. In this case, I can find anything, any property in my projectile motion. I use the equations of motion. I use the position, the vector, the acceleration vector. And I can solve everything. Any question about that online? Offline? There is another question, example, I will start solving it. If we have a cannon, before the cannon, you can see, I'll share my monitor now to just let me open the. By the way, during any quiz, you can use a worksheet which contains the relations. I don't expect you to carry all of these or any others. So you can prepare your worksheet. I will try to prepare that sheet and send it to you, but you can do it by yourself. This will help you to practice. You can use this worksheet and solve any assignment, homework, or quiz, okay, or exam. But if you, in the exam again, I talk about this many times. you don't need to use the book. It is useless, and you will lose your time. There is a question about the worksheet. You can use it anytime, any quiz, and you need some white sheets to just scratch sheets. And as I told from before, the first quiz you have 2 times to do it. I don't know who, I forgot who would contact me to ask about this point, but he can ask now, even on chat. He is online. I need to start 2-dimensional kinematics, DF5. Online, can you see my monitor?
Yes, sir.
Okay, thank you. We talk about this in the velocity and the rotational motion. This is the projectile motion. Aha, yes, here. The class, you can see that, right? Look at, there is nothing, we just need to talk about this motion. It is just like our example. If you look to the x direction of motion, there is a similar or equal distances each time. That is because we don't have any acceleration in x direction. But if you look at the same time periods, the vertical distance increased because we have acceleration in this direction. And the time is common between the 2 directions. Okay? This is what I need to talk about this point. And I will start more, not complicated. This is the same. We have the same tools. We will use it for this example. We have, this is the 0 level, and we have the down by 100 feet. We need to convert from feet to meters. We need to find something at the end. So I'll stop sharing and I will start talk about this example. Okay. Where is this? If you have any issue with your work, sometimes there is a fireman in my class. He needs my support. Anyone, if you need my support. So, where is this? No. So, if you have any issue, please contact me, and I'll try my best to help you in the exam time, in the quizzes, in the homeworks. Yes. So you are not alone in this course. We are all together. Now, let us start this example. We have this figure. We have this experiment. V naught is equal to 600 feet per second. Okay. The initial altitude is 100 feet. I need to find, I think, the range, which is the maximum x, also the maximum height, y max. I think we need to find the time also. The flying time all the time. What is the angle? 30 degrees. Alpha node is equal to 30 degrees. Okay. We need to use our equations, our formulas. Okay, now the way to solve any problem, we need to understand the question. We just have a projectile motion starting from a top of a shell or something like that. And the altitude of the initial motion is 100 feet. The velocity is given by feet per meter per second. We need to find the x range, the altitude, maximum altitude, and the time. Okay. We will use our relations as I said from before. This is the position vector r of t. Because you see everything will be in time. It is v naught multiplied by time cosine alpha naught in I hat plus v naught multiplied by time sine alpha naught minus 1/2. I put the minus directly. Now you can put G is equal to 9.8 directly also. G T squared. All of this in J direction. Also, the velocity vector is V naught. It is constant. V naught cosine alpha naught. Alpha naught 30, V naught 600, but I need to convert it in meters in I direction plus V naught sine alpha. This is V naught in Y direction minus G T J hat. You will see I can use everything, these equations to solve everything. And I am now need to convert from feet to meter. V naught is equal to 600 feet per second. I need to multiply it by the converting coefficient, which is 1. So this is over nothing. I need just to convert feet. So it is over 1 here because I don't need to do anything with seconds. Feet, I need to multiply by meter over feet just to cancel feet with feet. Each 1 meter is equal to 3 point something, I think, feet, right? Where's the next page? 3.1828. 3.28 feet. I can cancel feet with feet. 1 multiplied by second. So this is 600. 1 over this. One is 1. I have meters per second. This will be equal to V naught now will be equal to, it is 182.88 meters per second. What about the 100 feet? Okay. Multiplied by 1. The 1 is meter over feet, but I need to cancel feet with feet. It is here, 1 over 3.28. It will be equal to, I'll put it here, H, which is the height, is equal to 30.48 meters. I have everything in meters. I am safe. Any question about converting? Okay, now the maximum height. I need y max. What should I use? Should I use the velocity vector or the position vector? I don't have anything to do with velocity. I'm talking about position. So I will use the position vector. This is y. Y max, I don't know how much is it. I need to use this. V naught T sine alpha naught minus 1 over 2 G T squared. How can I find it? V naught, I know V naught. Sine alpha. Look, V naught sine alpha, it is Vy naught. G is given. What about T? I don't know T. From where can I find T? I am solving using this equation, but now I need to use the other equation, which is this one. At 2, no T. I need this bit of information. At y max, V y equal to 0. So I can find the time at that time, which is here. Vy is equal to V naught sine alpha, which is alpha naught, minus G T. Vy at that position is equal to 0. This is Vy max at y max. So this is the time at maximum altitude. This is equal to 0. So I can take this to the opposite side, it will be positive. I need to find the time, by the way. Then use the time here. Because this is y max equal to this. It is equal to this. So V naught at time max, I use this equation, this part, to find the time max. Okay, from here, move this to this side, it will be positive. It will be like this. Okay? Divide over G, the both sides, over G, G will cancel. Then T max is equal to V naught 182 sine 30 over G 9.8. It is just a number now. It is equal to, it is solved and where's the then the time is equal to 9.3 seconds. Look, that's right. If I need to find y max, I need to do more than one step. But all the steps are the same. I need to use an equation and find an unknown quantity. It is not difficult. It is not complicated. Just one more step. That's it. T max, I can use it here. Now, V naught is 180, 2 point something. The time it is given or found 9.3 sine 30, which is a half, minus 1 over 2 G 9.8. I put the minus there. The time 9.3, yes, squared. This will give me the maximum altitude, which is I have my calculator, I can't find it. Okay. In the sheets I found the R, but it's okay. The maximum altitude that we put it here, 182.88 multiplied by 9.3 multiplied by a half minus a half G 9.3 squared. Wow. It is 426 meters. Who can tell me, is this quantity above this point or this point? I use y0 equal to 0. In this part, there is another term which is y0 equal to 0. So my computed altitude is from the starting point here. It is 426. But if I need to find it from the ground, I need to add 30.48. This is the maximum height. Any question about that? Line. Can you find the X position? This position at Y max, this is X. From the vector X component, we can't find it. V naught 182 cosine 30 T at maximum height, we found it. You can put it here, then you can find X at maximum height. If you like to find the distance, which is R, then just use the Pythagorean theorem. Any question about this? Now, what is the time to reach this point, the final destination? From the position vector, how much Y final at this point? Y initial, it is here. Y final, it is here. It is downward. It is downward by this magnitude. It is negative 30.48 meters. I can put it there. Y final, which is equal to negative 30.48, is equal to the Y component of the position vector. It is V naught T sine alpha naught minus 1/2 G T squared.
I am talking about the final. Okay, so the time is final, the time is final. And I have everything is given. I have an equation with a second order in time. Okay. Now this is math. If I have this equation, a x squared plus bx plus c is equal to 0. And I need to find x. There is a general law to find it. By using this law, which is x is equal to, now in our equation is the time. So I will put it the time. It's t squared t. It is negative b plus minus. I have two solutions because I have a square. B squared minus 4ca over 2a. A is the coefficient multiplied by the square value. B multiplied by TC is the last term. In my equation here, I need to write it like this. I need just to move this part to there. So I have minus half gt squared plus v naught t g and all like that. I need to put it sin 30 t plus 30.48 equal to 0. This is the same like this. Half g with minus sign, it is 9 minus 9.8 over 2. This v naught, it is 182.88, I think, over sine 30 is 1 over 2, and this is the way to find it. Yes, you have it in the example here, but in the exam will be more simple. Okay. By using this, we have 2 times by solving this. We have 19 second, and we have minus 3.3 second. Don't worry now, don't give the important thing to solve this. Okay, just understand the physics. Now I will remove it because it is not important to me. And look to our question from before. You have this experiment. And you have 2 times. Which one you will accept? Is it 19 seconds? After 19 seconds, I will reach the final point. Or before 33 second, I was at that point. Who can tell me? Which one is accepted? There is no negative. Yes, you're right. There's no negative time. I need to use the positive one. What is the meaning of the negative time? If I complete my trajectory, then I will reach this point, which is the same altitude. This is at negative 0.33, but we don't have this in nature. So this is the accepted G at that time. Any question about this? And it is simple to find the range. Just put 19 seconds here, you will find the range. That's all I'll talk about the projectile motion. I start with a simple question, a simple example, and I finish with a little bit complicated one. It is not complicated, but to show you that I will use the same equations. I wrote two sets of equations, the equations of motions and vectors. Now I just put them here together, and you can use them anytime. You can write this in your worksheet and use it. You can solve any problem using them. With alpha equal to 0, alpha equal to 90, alpha equal to 44, and so on. Any question about this? Because I'll start talking about force and Newton's law now, because we have an hour. And this is the last lecture with too much or large number of sheets. Now we'll start with more simple. Now I have just 15 pages to talk about the force and Newton's law. Take a rest. By using vectors, this is the last note about this, and equations of motion. We didn't use the mass in any of our equations. If the object is a small stone or a big stone, it is the same, right? This is the first level to understand how nature is going. Now we need to use the next level, which is the Newton's law. Now we will use the constant acceleration, and we need to use the mass. Equations of motion. We have the acceleration is constant. We don't use the mass. Now, Newton's laws. We have A is constant, and we need to use the mass. The next level, we finish this, and we need to move here. The next level, energy, war, we have on here. A not equal to constant, and we use the mass. That's it. Then we will start, and we can use here also the momentum, the interaction between objects. Then we will talk about rotational motion. Rotational motion. We will repeat everything. Equations of motion, Newton's law, the energy. But briefly, we have a vibrational motion. We have fluids and some other selected topics at the end of our semester. We have the first exam here. We have the second exam here. We have the final exam here. This is our course. We have a homework, the last homework on the Newton's law, which is this lecture. We have also applications on Newton's law, which is tomorrow's lecture. And then I will start maybe with you or with myself, and I will record everything for you. The exam review, how to solve examples. I will solve more examples. The review doesn't contain the exam questions, okay? It's just to tell you how to solve. That's it. So don't put in your mind that is the review is the exam, or just with a little bit change in it. There is homework on Newton's law. There is no homeworks on the applications on Newton's law because we have the exam the next week, the next day. And you can submit your homeworks even in the next week. It's okay. You have a time to do that. Okay, let us talk about forces. What is the force? Who can tell me what is the force? When I was in your place or before, our instructors asked us about the forces. What is the force? We thought somebody asked answered as it's a power, it's an energy, it's a push, it's I don't know what it is. But it's the force is the physical quantity that represent the interaction between two objects. For example, this is the air. This is me. There is a force between me and the air, which is the gravitational force. It is an interaction language between objects in nature. If I am walking, okay, there is an interaction between my foot and the ground. I push the ground backward, the ground pushed me forward. Because of that, I am walking like this. When I push backward, then the ground pushed me forward. This is Newton's third law, you know about it. So this is the force. It is the interaction between the objects. We have many shapes of these forces. We have pushing and pulling. We have a rotational force like this. This is a rotational force. We have also contacting forces and non-contacting forces, just like the gravity. There is no need for the object to contact the ground, the earth, to attract it. Also, there is no need to two magnets to contact, to have a force between them, right? But if I need to walk, I should contact the ground. If I need to push something without any magnetic or electric or gravitational force, I need to contact. If I need to pull something, I need to contact. Also, we have 4 forces in nature. Our God created these forces for us. One of them is the gravity. One of them, the electromagnetic force, which is the interaction between charges and the magnets. One of them, or the other two of them, are nuclear forces between inside the nucleus. The force, we will see that the force is a vector quantity. It is not a scalar. So it has a magnitude, direction, and the unit. What is the unit of force? The unit of force is Newton, which is capital N. And it has the direction as we said. Name of sub forces, you can see that. We will study also the friction force, the normal force, we will see them, and you will apply these forces in the lab. We have something called superposition of forces. Superposition of forces, simply it is adding of force of vectors. Let us now, this is a ground, some ground. This is a box with mass M, and we have a force on it. The force is a vector quantity. It directs to the positive x direction. Okay. Then this object may or may not move to this direction. It will not move to the opposite direction. Even if that force is pulling, it is pushing now. I need to ask you now, what if this force is equal to 5? And there is another person is pushing by another force, which is 2. How much the total force acting on this object? Because these two forces are two vectors. One of them is 5, the other one is 2 in the same direction. Then the resultant force Fr is equal to how much? Simply it will be 7. The unit is in Newton. We will see what is in Newton is equal to. What if we have a friction force? The friction force, it is not bad force always. Sometimes or many times, the friction force is good for us. We will study the friction force and you will see what I mean. The friction force, it is an interaction force between an object and a contacting other object to it. If I need to push this box, there is a contact between this box and the ground. This contact will appear as a friction force. If I need to push forward, this friction force direction is backward. So I have friction force backward. It may be equal to, for example, to 3 in my example here. So I have 7 forward, I have 3 backward. How much the resultant force now after the 7 plus minus 3? It's minus. We have vectors now. Now the resultant force after all of this, F is equal to 7 minus 3, which is 4. In I direction. I am talking just in one direction now, right? What if I have a force not in X or in Y? Sometimes I have a force in Y like this. I am lifting the mass. I am leaving the mass, the air, the ground will attract it downward. I have vectors. As you know, we just finished the two-dimensional motion. I will use it. Simply. What if I have, this is X direction, this is Y direction, and this is my mass, my object now. I will not talk about mass.
and I apply this force on it. Assume this force is equal to 10 newtons. What is the direction of the motion? I should give you theta. Is it given here? This example is 30. As you know, I have a vector with the direction. I have x, y direction. Maybe this xy direction are horizontal and vertical. Maybe they are here. The ground of the room. This is y and this is up, which is z. And I have this force 10, and this is theta 30. I am pulling the object in this direction. Then the object will start moving or will start affected by this force. And I have two components. I have fx and also I have fy. How can I find that? Fx is equal to what? The magnitude of this force multiplied by sine or cosine? I'm asking now. Cosine. Why? Is it because I am in x direction or because I have the angle from that direction? Because I have the angle from that direction. So I have cosine 30. Here it is equal to f as a length sine 30. In this case, it will be equal, f is 10, the sine is half. This is 5 newtons. This is 5. This will be equal 10 multiplied by cosine 30, which is cosine 30. 8.66, 0.866. Then it will be 8.66 in newtons. In x direction. All of us know how to deal with vectors. Also, now we can deal with forces. These vectors. Just we change the name of the vector from A to F. That's it. Any question about this? I am now talking just about forces as vectors and adding and subtracting forces. I'm not talking about acceleration and Newton's law. What if I have an object here? Page number 3. I have, this is the positive direction, the other is the negative direction. We will see later what is the weight. The weight is the force attracting the object downward. Then we have a force downward. Assume it y, fy, negative direction. If I have this experiment and I apply a force, the object will start moving. If my force is
has a magnitude to start to do it move to act on it and starting the movement. طيب. Here, I have a force on this object to downward. For example, this is the eraser. All of you can see it. And this is my coffee cup. There is a force downward. Why this mass or this mass or me or you doesn't go downward? Cut them. This is the mass. There's the downward force. It is not going downward. But this is the force, the mass starting moving. What is the reason? If I push it in this direction, it will start moving. In this case, I have a surface. This surface, there's a contact between these two objects, the surface and the mass or the object. For example, if my force downward is 5 newtons, there is a reaction force. You will see that it is upward. We can name it. This is Fy in positive direction. We can name it the normal force. It is upward or normal to this surface. It prevents that object to go down that surface. But now, how much this force? If this one is 5, how much is this? Assume it is 3. Then 5 is bigger than 3. Then the object will start moving downward. That's happened many times. If I stand up on sand, then my force downward is bigger than the normal force on the sand. Then my foot will start going inside the sand until the normal force is equal to my weight downward. What if this force is 7? 5 to down, 7 to up. What will happen to this object? It will start moving, it will start flying. Okay, but it is not flying. So how much the force? It is not below, it is not bigger, it is the same. The reaction force or this force will be the same. If the forces are the same, and now I need to start understanding my system, I have the force as a vector is equal to Fx in I direction plus Fy in J direction. It is simple, we know that. How much Fx? This is X. Do I have any forces in X direction? No, I don't have. There is no forces or horizontal forces. What about the Y forces? I have -5 plus 5 in J direction. I have -5, I have +5 in Y direction. In this case, I will not put them like this. I can put them the summation or the total forces in Y direction. It is equal to 0. Also here, even if I don't have any forces in X direction, I have the summation of X direction forces. It is equal to 0. If my forces in X direction and Y direction are 0, then the total force is 0. And the object is, there is no forces of that. Even if there is a mass or a weight downward and the reaction, normal force upward. If I ask you, even you will see that in the lab, what is the forces on this cup, on this object? You cannot say it is 0. It is not 0. We have two forces. One of them is the weight, the other is the normal. The total force is 0. It's okay. What if I start pushing the cup, but it is not moving? I start put small force, maybe Fx is equal to positive 0.01 Newton. It is a small force. There is a friction force here, and this friction force, this is example how, what if an ant is come and start pushing this object? It will not push it. What if I come to push a car and it is stagnant? I cannot push it because the friction force, not because the car is heavy. If I start pushing the car forward or backward and the handbrake is off, I can't push it because it is heavy. We will see that I will push it slowly. But what if the handbrake is turned on? I'll start pushing the car. It will not slide because the friction force is very big to me. So the friction force, I have a friction force in x direction. This friction force will be equal to how much? Now I am asking. It is the same as the normal force, the same concept. If my force pushing is 1 Newton, if the friction force is 0.5, then my force here is bigger. Then the object will start moving, right? But the object is not moving. What if the friction force is 5? I have 1, 5. Then the 5 will win. And the object will start moving in this direction. But the friction force will not move the object. So the friction force should be equal to the acting force. That is if the object stays stationary. And this friction force is named friction force, stationary friction force. But if I increase my force to be 2, sometimes if I increase, then also I cannot push and move the object. That is because friction force, stationary, can be changed. It will be 2. Then I change to 5. Then it will be 5. That means the friction force, stationary friction force, is not constant. It depends on my pushing. What if my force is 0? Then the friction force is 0. That is because the particles here is interact with the particles down like this. If I push slow, if I push with low force, then the interaction is low, then the friction force is low. If I push strong, then the interaction is strong and the friction force is strong. But what if I push with the much strong force? Then the particles will break the contact between them and the other object, and it will start moving. The friction force in this case, the stationary friction force, will be removed all. But I will still have another friction force, which is F kinetic, which is you moving, because I am moving and I don't know if you hear. Oh, you can hear the sound, the interaction between my hand and the ball. This is because the friction force. But it is the friction force, the kinetic friction force. This one is constant. Maybe it is a 3. It will stay 3 for a constant velocity. It depends on the velocity. So this is the friction force. I'm talking about it because I need to talk about the y component of the force and the x component of the force, and how to deal with the horizontal components and the vertical components. What if I need to find the magnitude of that force? Yes, Salam. It is the same as the magnitude of that vector. The force, it is simply Fx squared plus Fy squared. This is the Pythagorean theorem. And what is the theta of that force? The direction of that force. It is tan inverse to Fy over Fx, simply as we know from before. And also we can use cosine inverse and sine inverse. Any question about that line here? We are now talking just about vectors. Start solving a problem, we need to start to choose our coordinates, x and y. Originally, we choose this is x and this is y. But sometimes this is not work with us. For example, if we have this head and we have this object, we need to start solving this problem. And the motion along this direction, like you can hear. So it is not suitable to choose this is x and this is y. We can solve it, but it will take more steps to solve it. But if we take this is x and this is y, it will be more simple. Sometimes we have this system and the object is here. It is better to use this is x and y. There is another coordinate system also we can use it. Also in the lab, you will see you have this system. This is a wall, this is the ground, and this is a ladder. It is okay to use it x and y like this. Sometimes you can use this is y and this is x. Because when the ladders start sliding, it will move to this direction. So it is okay to choose your x and y as you like. For example, we have this sliver and we have a mass here. We have a ball. We have the weight downward. We will see what is the weight. It is a force. Let us assume it F due gravity. Also, we have a wind force. Force due wind. Just like that. And I tell you to start, what is the forces in that object? We need just to consider our coordinates. This is the x direction, this is the y direction. This is theta. Because this is the theta, we can see that this is also theta. This is also theta. This is negative y. This is positive y. This is negative x. Now decompose our forces. We have this force. This force is not on y, even not on x. So it is with an angle from the negative y. We need to find its components. Then we have now F geogravity on the negative y to this direction, and we have another component here. It's like this. This is x, this is y, the positive, and this is Fg, and this is no, push it like this. F wind. Okay, find the component of each force. The gravity force, it's okay, it's starting from the origin. But this force, it is not starting from the origin. We need to move it to start it from the origin. Just I need to move it to here. This is F wind. So the force of the wind will push to this direction. And this is theta, and this is theta. I have the components. It's simple to find them. This one is Fg. Is it sine or cosine for theta? For it is in the direction of theta. Don't look at the axis. Is it y or x? The direction of theta is cosine theta. It is on the negative y. Here, it is negative x. But I have here at this on this axis, it is Fg sine theta. Because theta on the opposite direction, the force. What about here? Okay, I have here F wind cosine theta, because I have theta in this direction. And here F wind sine theta. It is just vectors, but these vectors are forces. Now, I have a force vector, and this force vector is F is equal to Fx I hat plus Fy j hat. What is the forces in x direction? The summation of the forces in x direction, I have the positive forces and negative forces. Positive, it is positive F when cosine theta minus F from the gravity side theta. What is the y forces? Both of them are in the negative direction. So it is negative F with sine theta minus F gravity cosine theta. Again, it's just big. If I give you, what is, if I told you this thing, theta is equal to 30 degrees. F with Fg, this is equal to 1000. In Newton, this is equal to 2000 in Newton. Then you can solve. But before, forget you are a physicist now. You are just studying vectors. You have two vectors. I gave you the direction of each vector, the magnitude, the length of each vector. And I just ask you to find the x and the y components. My xy plane is not like this, it is like this, right? Just I move it, I rotate it. Okay, from page 3, 4, 5, 4 and 5, this example, just talking about force as a vector. Now I will talk about Newton's law. We have 3 laws for were put by Newton. And also we have the gravity, the gravitational general law. This example, just to talk about this. A, B, 2 vectors. This is equal to 3 I hat plus 5 j hat. This is equal to minus 2 I hat plus 3 j hat. What if I ask you to find C is equal to A plus B? It's the same. Okay. C is equal to this plus this, the component plus the component. 3 minus 2 is 1 I hat plus A j hat. That's it. I gave you 2 vectors. One of them comes from the wind force. The other one comes from the gravity force. I need from you just to find the resultant vector, and then you can find the length of that vector, which is the force, and you can the direction. Find the direction. By the way, you will see a question like this in the exam about vectors. This is small hint. Now, Newton's law. We have the first one. It's simple. This is page number 1. I didn't number the pages. The first law, Newton's motion, talk about what if we have a 0 force on, this is a 0 force on any object. This object maybe has a velocity equal to 0 or a velocity, I'm talking about velocity, not a speed. Velocity, which is a vector, equal to a constant. The constant means constant magnitude and constant direction. In the outer space, if you throw something with a velocity 5 in that direction, it will still go with the same speed, the same direction. There is no friction force, there is no gravity away from any planet or star. It will stay moving constant. There is no force on it. It has its velocity. There is no acceleration because there is no force. It will stay moving until infinity. Okay, what if its velocity with respect to us? Because we know we have a relative velocity. What is if its velocity with respect to us is 0? And we have 0 force. I'm asking now, with 0 force, is there any change in its physical nature or motion? Or it will not change its motion, right? Also, if it is moving with constant velocity, uniform velocity, it will not change. It will stay like that. This is the first Newton law. It is the law of the 0 force and the 0 acceleration. It is simple. We have this object. It has its weight downward and the normal force upward. And the summation of these forces in y direction is equal to 0. This obeys Newton's first law. If I apply a force from here, which is 5, and you apply another force from here, which is also 5, it obeys Newton's first law because the total force is 0. Any question about Newton's first law? Huh? I will talk now. We have Newton's second law, which is the law that has, or that has, I don't know, the most of the applications, even the next chapter, yes. Also, the third Newton's law has an application. But now I will talk about Newton's third law, and that's it for today. And I will start talking about Newton's second law tomorrow and start solving applications on that law. And what? And that's it. We are done for the, yes. Newton's third law. In our nature, we have many objects. Between any two objects, there are an interaction. Maybe these two objects are away from each other, like this. This is the moon, this is the earth. They are not contacted. Maybe they are on contact. Newton's third law. There is, for any force, for any action, there is a reaction. And that reaction, it is the same force, the same in magnitude, but in opposite in direction. The earth now attracts the moon to its center. Also, the moon attracts the earth to its center. The forces are on the same line. If I am here, the earth attracts me to its center. Also, me attract the earth to my center of mass. We'll talk about it. Also, any two objects, maybe a person and another person. It's not emotional, okay? It is physics. There is an interaction between them, which is gravity. Even, and this, you can see that on YouTube. There's a attractive force between any two masses. Maybe this mass and another mass. If you put them and there is no friction force, no gravity, for example, if you put them away from the earth, they will start attract each other. And this is the way how the stars are start to find sun and the planets. It's just small dust pieces attracted, and they combine all the planet or the star. This is not contacting force. Also, we have contacting forces. In the car, if the velocity of the car is 50 kilometers per hour, that is because there is a part in the car is moving in the same velocity but in the opposite direction. Do you know that? There's a piece in the car moving in the same velocity but backward. Who can tell me where's that piece? The tires. This part the lowest part, the contacting part of the tire with the ground is moving backward with the same velocity, kilometer per hour. Because of that, it acts on the ground backward. Because of that, the ground acting on the body of the car forward. This is action and reaction force. Also, our motion, we are pushing, as I said from before. I push the ground backward, it's pushing me forward, and so on. You will see also the rockets. There is a backward momentum and a forward momentum, and so on. The normal force also, and as I said, if there is a force, from air on moon, there is a force from moon on air. They are equal but opposite in direction. They are the same but opposite in direction. I am sorry, it's a long lecture, I know that, 2 hours. It's physics. And but we need to finish everything in our time, just a month. We are done today. I'll give you 5 to 10 minutes to be free. Any questions? As always, if you need anything, just contact me. I have my office hours. Also, you can contact me anytime to meeting. Thank you. See you tomorrow.